Assalamualaikum and good morning students. Today we're going to learn about the properties of limit. So we got here the first property, which in this form you can see the limitation x approaches a. Then you got the constant and the function. You can also write it as the constant limit approaches x a. So on to the next properties, which we have the limitation x approaches two functions, subtraction or addition. We can also write it as limitation x approaches a, the function f plus minus the limitation x approaches a, function g. So onto the next properties is the same as the second one, which we have two functions, where the difference is these two functions will be a multiplication. So like this, like the previous one, we can also write it as x approaches a, function x multiply limitation x approaches a, function g. So the next property is also the same as the second and the third one. But this form we have in fraction. Fraction, as we know, is divide, right? So we can also write it limitation f x approaches a over limitation x approaches a gx. And last but not least, the final properties we have limitation x approaches a c. What is c? C is the constant. So we will get the answer is also constant. So we move on to the example first. The first example we have limit x approaches to 4x. So we remember the first properties, which we bring out the constant in front. So we can write it like this. We bring out the constant is 4, we bring out in front, limitation x approaches to x. Then we can just substitute the x equals to 2 and the answer will be 8. Move on to the second example, we have limitation x approaches 5, x squared plus 4x plus 3 over x squared plus x minus 2. So we use the fourth property, which is limitation x squared x approaches 5x squared plus 4x plus 3 over limitation x. This will make you a little bit easier to understand because you know which you want to substitute. So we do the normal substitution. 5 squared plus 4, 5 plus over 5 squared plus 5 minus 2, and then your final answer will be 12 over 7. So we move to our last example of the day, which we have the limitation x approaches 3. Then we have two functions, just like the third properties, which is x plus 3 and x plus 4. This is the multiplication. So we can write it like this. Limitation x approaches 3, x plus 3 times limitation x 3 x plus 4. We do the normal limit, which we substitute the 3 plus 3 times 3 plus 4. We get here 6 and we get here 7. 6 times 7 equals 42. That's all for today. Thank you for watching.
Hello everyone, I'm Rekvanan and today we are going to learn.
Find the area under the graph of two functions.
So, from the previous chapter, we know that if we sketch a graph and we want to know the area under the graph, we can find it by integrating the function from the given interval. But what if we have two or more functions? Let's say we have fx equal to x and gx equal to zx. If both of these functions were on the same axis, then they will create a bounded area. The question is, how will we find the bounded area? Let's make it as a shape, So to find the red region, we can subtract some shape. So the first shape came from the gx function, which is zx. And the second shape came from the fx function, which is x. Then, to find the area, we can just integrate the gx function minus the integration of fx function. We can proceed to the calculation by integrating them from 0 to 1, and we get the answer, which is equal to 1 over 6. To make it easier, let's understand it like this. I first need to determine the upper function of the area, which is gx, and the lower function of the area, which is fx. So to find the area, we can just integrate the upper function minus the integration of the lower function. Let's move on to some example. So the first example, determine the area of the region enclosed by y equal to x squared and y equal to zx. Using our previous idea, we first need to determine the upper function. So integrate the upper function, which is zx minus the integration of the lower function, which is x squared from 0 to 1, then we get the answer 1 over 3. Moving on to the next example, this is a bit different because we have two shapes. So let's call it 1 and 2. But we don't have the interval yet. So we can find it by finding the point of intersection between those two functions, and then we get point of intersection which is 0, -2, and 2. Now we can proceed to the calculation of the first area. Remember, upper function minus lower function. We integrate them from -2 to 0. Then we get the area of the first shape to be 4. Now, let's move on to the second shape. This one is a bit different than the first shape because the upper function and the lower function is different. So the upper function will be x and the lower function will be x power 3 minus 3x. But if we calculate them, we also get the same answer, which is 4. So, to find the total area, we add the first shape and the second shape, which is 4 plus 4 equal to 8. Moving on to the last example, find the area bounded by y equal to zx, x equal to 1, y equal to 1, and y equal to 2. So this was the area. Yeah. But it's different because now we have the interval on the y-axis. How? Okay, let's make it familiar by rotating and flipping the graph so that the y-axis became the horizontal axis. So we flip the graph and we also need to flip the function. How do we get this function? Well, because we have the original, which is zx equal to y, then we square both of them, then we get x equal to y squared. Now the upper function will be y squared and the lower function will be y. If we rotate it back to the original, the upper function will be the right function and the lower function will be the left function. So, to find the area, we can integrate the right function minus the integration of the left function. But we have to integrate them respect to y, because we are talking about the y-axis. So we substitute the function. Where did we get this? Well, it's from here. Now, we integrate them from 1 to 2, and we get the answer, which is 5 over 6.
Assalamualaikum warahmatullahi wabarakatuh. Today, I will be teaching you guys about first principle. As you guys can see here, I stated the formula that we will use in first principle. we use this formula to define a derivative of a function. So, before this, we have learned about if we have a function, let's say it is x to the power of a. If we want to differentiate it, we will basically get f prime. The power, we need to bring it forward first, right? So, the power, we bring it first, write it back, and the power, we minus it with 1. So, that is a basic knowledge that we will learn before. Okay. Today, I will show you how to do it with first principle. Let's say we have a function of x squared plus 3x minus 2, So, if we differentiate it with the basic knowledge we just learned, we will basically get this 2x, this one 3. And since this one does not have x, we just leave it away, right? So, can we get the same answer if we use the first principle? Okay. I'm going to show you. So, lim h approaches to 0, f x plus h. Basically, we just substitute the x with this. So, let's do it. X plus h to the power of 2 plus 3 x plus h and minus 2, right? And we minus with the fx. What is the fx just now? X squared plus 3x minus 2 over h. Okay. After that, we expand all of it. H minus this, we will get x squared plus 2hx plus h squared, and this 3x plus 3h. Sorry, this is supposed to be 2 minus 2, and this minus minus x squared minus 3x. Since negative meet with negative, so it will be plus, plus 2. I'm sorry, over with h. Okay. From this, we see that we can cancel this out because positive, negative, 0, and also this, and also this. So, we left with 2hx plus h squared plus 3h over h. And now, since we have h on the bottom and we have h on top, we can cancel it like this. 2x plus h to the power of 1 and also 3, and also 3. Okay, now the last step, we need to substitute the h with 0. So the final answer is 2x plus 3. See, we get the same answer. So that's all from me. Thank you.
Mr. Muhammad Ifah bin Shamsuddin. My matric number is D2024-1111-300. So today I will teach you about limit and continuity. Are you ready, guys? Let's go! Okay guys, today we will learn about limit and continuity for Calculus 1 subject. Okay, first of all, we need to know the three objectives why we learn this topic. First of all, we need to understand the continuity concept. The second one is we need to understand three conditions of continuous function. And the last one is we need to understand the example of continuous and discontinuous function. Okay guys, these are three conditions to determine the function is continuous. First of all, the function is defined at C. For the second one, the limit of fx as x approaches C exists. And the last one, the limit of fx as x approaches C is equal to the function value at C. Remember that. Let's look at example 1, where the function is fx equal to x plus 1. First, observe the graph. This is a straight line, and from the visual, it's clear that the function is continuous and defined for all values of x. Now let's break this down step by step. Limits exist for all points. Since this is a linear function, it is continuous everywhere. So the limit exists at every point. The value of the function fc also exists between all c. For any point c, you can directly substitute it into the function to get fc. For the last one, the limit and the value of the function are the same. This means that as x approaches any point c, the limit of fx equals fc. Now, let's focus on the specific calculation when we substitute a equal to 5. First, evaluate f5. When we substitute f5, then we get the answer is 11. So the function value exists. Next, confirm that the limit as x5 also exists. When we substitute limit x5 to the function, we also get the same value, which is 11. Thus, the function value and the limit both equal 11 at x equal to 5, which verifies the statement that the limit and function value are the same. So that means this function is continuous. Now let's move on the example 2, where the function is fx equal to 1 over x. Looking at the graph, you can see that the function has a vertical asymptote at x equal to 0, which indicates that the function is not defined at this point. Let's analyze why this happens. The function f0 is not defined. When we substituting x equal to 0 into the function, it will give us f0 equal to 1 over 0, which is undefined. Since f0 does not exist, we cannot calculate the value of the function at this point. Okay, since this function did not satisfy the first condition of the continuous function, so we don't need to look to the second and the third conditions anymore. Since f0 is not defined and the limit at x equal to 0 does not exist, this function fails to satisfy the conditions for continuity. Therefore, fx equal to 1 over x is this continuous function at x equal to 0. Okay, now let's analyze the last example where the function is defined piecewise. Fx equal to x squared for x less than 1, fx equal to 2x plus 1 for x more than or equal to 1. This example demonstrates a function that is not continuous at x equal to 1. Let's check what happens at x equal to 1. First, function value of f1. Since x equal to 1 falls in fx equal to 2x plus 1, we calculate the f1 and we got the answer is 3. So that means the function exists. For the second one, limit at x equal to 1. For the left hand limit, we will substitute x1 to the function of fx equal to x squared, and we got the answer is 1. For the right hand limit, we substitute the 1 to the function of fx equal to 2x plus 1. But we got the answer is C. Since the limit for the left hand and the right hand are not equal, the over limit does not exist. So the function is discontinuous at x equal to 1 because the left and right limits are not equal, causing a jump in the graph. Hey guys, thank you for watching, and don't forget to do your own practice because practice makes perfect. Okay, bye.